frozen on Facebook, so you guys will have to keep an eye on Facebook for me. Here we go again. How are we doing there, Mike? We up on Facebook?
It looks like we are, yeah.
Okay. You'll have to watch the comments for me because I can't see them again. Here we go. Try this again. Okay. How long is this? Can we stretch this right out for the whole hour, Paul? Or?
Sure. It's probably about a 4-minute song.
Yes. Played 20 times.
This is a song that never ends. Yes, it goes on and on, my friend.
There you go.
Hey, awesome. Okay. Hey, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. First of all, I'd like to welcome back our regular co-host, Royal Astronomical Society of Canada member, Mr. Paul Owen from the Moon Shadow Observatory in Hampton. Hey, Paul.
Hello.
Evening. And Royal Astronomical Society of Canada member, Mr. Mike Powell from the PFO Observatory here in St. John. Welcome, Mike.
Hello.
Okay, folks, on tonight's program, we're going to continue our discussion around getting your telescope in top shape for viewing by looking at collimation. Last week, Paul gave us some great pointers on collimating a Schmidt-Cassegrain telescope. And this week, Mike's going to show us how to properly collimate a reflector style telescope, which is a very popular style telescope. Also on tonight's program, we're going to take a look at another interesting current space mission in our new Where Are They Now segment of the show. And this one is actually one of the longest missions that JPL has been running, and probably not very well known either. Then also Paul's going to provide us with another interesting Rosanna's Fun Facts episode, and Mike will return with another one of our new segments, his Binocular Target of the Week. And that'll kind of run into, I won't say what that's about, but I know what it's about. Hey! And we'll take a look at your wonderful photo submissions for the week, and we'll talk a little bit about our current Shoot the Moon contest that's going on right now. Also a bit of discussion around our newest offering of workshops coming up, which is based really around beginners. And of course, we'll take all your questions about stargazing, telescopes, and more. So sit back and enjoy, everybody, and remember, this is a family-friendly live broadcast, so if you have any questions about the night sky, we're more than happy to try and answer them here for you. So I guess let's get started with our first look at our newest segment, Where Are They Now? Not our first look at this one, apparently. So, okay, that's up to me, I guess. So we're going to go to present now, and I'm going to present entire screen. We'll save this screen, and I'm going to go to full screen. And I just want to be sure, first of all, that we've got everything up and running. So we'll be sure that we can see this slideshow from beginning.
Where are they now?
All good? Hey, where are they now? Where are they now, anyway? Lots of kind of weird orbits there going around, but still lots of activity, lots of exploring going on in the solar system and beyond. So tonight's topic is going to be about the Mars Odyssey spacecraft. And this is not a very well-known spacecraft that's been orbiting Mars now for 20 years. Unbelievable that they've created a mission that can last that long, at least. But we're going to carry on, and I'm just going to start out with a little bit of a dramatic music video. Here we go. I love NASA because they put all these dramatic music videos in. Hey, that didn't hurt a bit. Anybody still there?
Oh yeah.
Okay.
All's good.
You guys go too quiet on me.
It's called mute, so we don't interrupt.
All right, so NASA's 2001 Mars Odyssey spacecraft launched 20 years ago on April the 7th, making it the longest continually active spacecraft in orbit around a planet other than Earth. Now, the orbiter, which takes its name from Arthur C. Clarke's classic sci-fi novel 2001: A Space Odyssey, was sent to map the composition of the Martian surface, providing a window to the past so scientists could piece together how the planet evolved. It had already completed its primary mission by 2004, but because of its immense success, NASA decided to extend the mission at least 7 times now. But it's done far more than that, uncovering troves of water ice, serving as a crucial communications link for other spacecraft, and helping to pave the way not just for safer landings, but also for future astronauts. Now, to contribute to the science goals, Mars Odyssey has the following science objectives: globally map the elemental composition of the surface, determine the abundance of hydrogen in the shallow subsurface, acquire high spatial and spectral resolution images of the surface mineralogy, and provide information on the morphology of the Martian surface. Characterize the Martian near-space radiation environment as related to radiation-induced risk to human explorers as well. Now, to accomplish this, the Mars Odyssey orbiter is equipped with 3 scientific instruments that it uses to explore the Martian surface and atmosphere. The Gamma Ray Spectrometer. Now, this device measures just how much hydrogen exists in the upper 3 feet of the planet's soil. The amount of hydrogen found gives scientists some evidence about the existence of water on Mars. The second experiment is the Thermal Emission Imaging System, or THEMIS. This instrument identifies rock and mineral types on the planet's surface and searches for traces of hydrothermal activity. Information gathered from THEMIS helps determine safe landing sites for future missions. And the third experiment is called the Martian Radiation Environment Experiment, or MARI. Now, scientists are curious about the amount of radiation that humans will be exposed to during a possible manned mission. MARI gathers data about the radiation on the planet. Now, the Odyssey orbiter is also a communications relay, of course, for rovers and landers on Mars, including the Mars exploration rovers Spirit and Opportunity, which of course have since expired, the Mars Phoenix lander, and the Mars Science Laboratory's Curiosity rover, and now, of course, the Mars Perseverance rover, along with Ingenuity. Images and other measurements from Mars Odyssey help identify potential landing sites for rovers and landers. Mars Odyssey has contributed numerous science results. It has mapped the amount and distribution of chemical elements and minerals that make up the Martian surface. Maps of hydrogen distribution led scientists to discover vast amounts of water ice in the polar regions buried just beneath the surface. Odyssey has also recorded the radiation environment in low Mars orbit to determine the radiation-related risk to any future human explorers who may one day go to Mars. Now, for 2 decades, the longest-lived spacecraft at the Red Planet has helped locate water ice, assess landing sites, and study the planet's mysterious moons. Here's just a partial list of Odyssey's many accomplishments. Mapping Martian ice. Odyssey's 2 decades of data have been a boon for researchers working to determine whether water ice is locked up on the planet. Understanding the water cycle on Mars, a planet that was much wetter at one time, like Earth, offers insights to the way it has changed over time. How does water move around the planet today? Does the tilt of the planet affect where ice is stable? Odyssey's discoveries have helped chip away at those questions. Stores of water ice are also needed to help astronauts survive on Mars and to provide fuel for their spacecraft. In fact, astronauts were the focus of an instrument aboard Odyssey that measured how much space radiation they would have to contend with before it stopped working in 2003. Now, the orbiter finds the water ice using its gamma ray spectrometer, which has proven to be a capable hunter of near-surface hydrogen, a proxy for water ice. Now, the GRS measures the amount of different elements on the Martian surface and also serves as a node in NASA's interplanetary gamma ray burst detection, which identifies sources of gamma ray bursts for follow-up astronomical observations. Of course, what Mars is made of. This is the other part of it, the mission. Look at almost any mapping study of the Martian surface, and it probably includes Odyssey data. For many years, the most complete global maps of Mars were made using Odyssey's infrared cameras, called the Thermal Emission Imaging System, or THEMIS. The camera measures the surface temperature day and night, allowing scientists to determine what physical materials, such as rock, sand, or dust, exist. Its data reveals the presence of these materials based on how they heat up or cool down over the course of a Martian day. Now, the net effect of 2 decades worth of all that mapping, scientists haven't just used the data to map valley networks and craters, they've also been able to spot sandstone, iron-rich rocks, salts, and more. Findings that help lend deeper insight into Mars' story. Now, Themis has also sent back more than 1 million images since it began circling Mars. The images and maps it's produced highlight the presence of hazards such as topography features and boulders, but they also help ensure the safety of future astronauts by showing the locations of resources such as water ice. Now, this aids the Mars science community and NASA in deciding where to send landers and rovers, including the Curiosity and Perseverance rovers, which touched down on August the 6th of 2012 and February the 18th of 2021. So there's the two sites, Gale Crater and Jezero Crater. This is where Curiosity landed, and that's where Perseverance landed. From early on, Odyssey has served as a long-distance call center for NASA's rovers and landers, sending their data back to Earth as part of the Mars Relay Network. The idea of Mars Relay goes back to the 1970s when the 2 Viking landers sent science data and images through an orbiter back to Earth. An orbiter can carry radios or antennas capable of sending back more data than a surface spacecraft. But Odyssey made the process routine when it began conveying data to and from NASA's Spirit and Opportunity rovers. Now, each day the rovers could go somewhere new and send fresh images back to Earth. Through a relay like Odyssey, scientists got more data sooner, while the public got more Mars images to be excited over. Odyssey has supported over 18,000 different relay missions so far, relay sessions. Excuse me. These days, it shares the communication task with NASA's Mars Reconnaissance Orbiter and MAVEN, along with ESA's European Space Agency's Trace Gas Orbiter. Now, Odyssey has done such a thorough job of studying the Martian surface that scientists have started turning its Themis camera to capture unique views of Mars, Phobos, and Deimos. As with the Martian surface, studying each moon's thermophysics helps scientists determine the properties of materials on their surface. Now, such information can offer glimpses into their past. It's unclear whether the moons are actually captured asteroids or chunks of Mars, blasted off the surface by an ancient impact. Now, future missions like the Japanese Space Agency's Martian Moon Exploration, or MMX spacecraft, will seek to land on these moons. In the distant future, missions might even create bases on them for astronauts. And if they do, they'll rely on data from an orbiter that began its odyssey at the start of the millennium. It is yet unknown as to the end of the Mars Odyssey mission, over 20 years now. Budget cuts were forecasted in 2021, but no decision has been reached yet. This little orbiter is a true testament, really, to the ingenuity and engineering involved with the amazing people at JPL and NASA. They're getting better and better with their mission life expectancies. Spacecraft warranties really don't seem to matter too much anymore. And that's my presentation on the Mars Odyssey.
Well, eat your veggies.
Eat your veggies. Don't slouch.
Yes.
Yeah. So kind of an interesting little spacecraft. I knew that it was out there. There's a few spacecraft, of course, now that are orbiting Mars that are sending back data. They're kind of combining their data so that we can get data a little bit faster, for one thing, and because they orbit the Mars at different times, they're able to pick up more of the data. We've got Curiosity up there right now. We've got what's the lander that's having trouble digging up there? I'll have to do a talk on that one next week.
Oh, that's Scratchy.
Huh? Scratchy?
Itchy or Scratchy?
Itchy and scratchy.
And of course, we got Perseverance rover with Ingenuity, which is supposed to take its first flight tomorrow, as far as I'm aware now. So
yeah, that'll be interesting to see if they get it up and going.
Yeah, they'll be coming down with a few images, I guess, first of all, and then after that, hopefully, maybe even some video. So we'll have some images of it flying over the top of the rover, looking down on the rover, taking pictures of its shadow, that kind of thing. And then the rover looking up at it too, taking photos of it. So it should be pretty amazing. We're doing all this on another world. Pretty amazing stuff.
Yeah, absolutely.
Okay, so gee, look at that, 8:16. We got lots of time.
Yeah, you're flying
My
tonight.
goodness, I was.
Geez, you must have had about 4 cups of coffee to get all that out of you. There you go. I knew.
That was 25 slides, and I did all that in 10 minutes. Wow, awesome.
Yeah,
Okay,
that's quick.
that is quick. Okay,
Yeah.
let's go on with our collimating a reflector telescope. Michael's going to give us our topic on collimating. Yeah.
You've been saying no for a couple weeks now.
I will slow it down.
Slow, Mike.
Come here, toy. I just so happen to have one with me.
There.
Keep on blue shield.
I have it with me when I have it with me.
It looks like a fingernail.
Does, yeah.
Hey, that's the greatest little rig.
You can scratch his back with that.
Yeah. Oh,
What is this? Anyway, it's a 114 Skywatcher with a 500 millimeter focal length. It is a beautiful little scope. You want to talk about grab and go? That's the toy.
Yeah.
And it's on one of these Explorer Scientific Ultaz mounts.
they're great
Which
mounts.
makes it nice and steady. So
Yeah.
it's a great rig. Great rig.
Yeah, it'd be much better than an EQ1.
Oh, yes, absolutely. I'm saying that. It's on a collimation, somebody told me. So I have to go ahead and collimate.
Wow.
So this, first off, I'll take out what I call my desiccant eyepiece that I made. You got a 35 millimeter film canister. You drill 4 or 5 holes on the bottom. You open it up, and anytime you buy electronics, you get those little desiccant bags. Don't throw them out. Pill bottles, keep them. You put the desiccant bag inside your little cap, and guess what? You now have a desiccant eyepiece that goes into your scope and keeps it nice and dry. You'll never get moisture in there, and it lasts a lot longer. So that comes out. Now, I showed once before these laser collimators. My suggestion would be, if you have a reflector telescope, get yourself a laser collimator. It makes life so much easier. It's fairly simple to use different types of collimation tools on a small little reflector like this one. But if you got a Dob, and like a 10-inch Dob or a 12-inch Dob, you're going to need 2 people to collimate it, because you'll need one at the front, one at the back, because there's no way you can look in and see. If you're at the back end adjusting the mirror, you can't look up and see at the front what's going on. Using a laser collimator like this one, you can. Once again, I'll quickly just show how fast and easy it is to use a laser collimator on these things. First off, you just turn on the laser, and we have light. Shove that in the eyepiece. Now, if I was using a Dob telescope, you can see the light reflect off the mirror, come up into the hole here. I would turn this to the back of the scope, because that's where I'm going to be doing most of the secondary work, is at the back of the scope. Normally, when you fire it up, you want to look in. Most reflectors of any quality have a ring in the center of the primary mirror. What they look like is those little sticky tabs you used to put on your loose leaf circle. And that shows you where the center of your mirror is. If you don't have that, take a good guess. I've seen people actually take their mirrors off and mark the center with a dot, with a black marker, just so they know where center is. It doesn't affect your views. It's just a little black dot in the middle so you can center your mirrors up. So the first thing you want to do when you get your collimation eyepiece in here, your laser in there, this particular scope uses a 2 millimeter Allen key. And on the front, where your secondary mirror is, there's usually a Phillips screwdriver in the center, and that is to adjust the whole mirror if you had to rotate it or something like that, the secondary mirror. And then it's got either 3 little set screws that could be Phillips or these Allen key type, or you can put Bob's knobs on there. And Bob's knobs just make everything easier. As Paul showed last week, they're there. You just got to tweak each one. You don't have to worry about getting this little key in that little hole in the middle of the night. But what you want to do is fire the laser on, or first, put your Allen key in and just give ever so small adjustments to the left or right until your laser is centered in that dot on the mirror. You might have to go around once or twice, just ever so small and loose, clockwise or counterclockwise, until that dot ends up in the center. Once it's in the center of the primary mirror, you go to the back of your scope, and there's usually 6 different screws here. There's 3 small ones, and what they do is they lock the primary mirror. Their primary mirror locks so it doesn't shift. You want to give those anywhere from half to 3/4 of a turn loosened so that you'll be able to take the other 3 knobs, which are usually the bigger ones. If I can tip it up this way, you can see the larger ones. That's actually for adjusting the tilt of your primary mirror. So now that I've loosened off the 3 little ones and I can get the mirror to move, I'm going to spin this around, and I'm going to look down the center, and I'm just going to adjust this a little bit each way. And if you look at the target here, you'll see the laser comes out and it goes away, and it comes out and it goes away. What you want to do is eclipse that laser in a little hole that's in the center of your laser collimator. Once you center it in there and you eclipse the laser so you can't see the dot anymore, like there's the dot bright and loud, you'll know it. Then once it's in there, you are centered and collimated. You go to the back again and you tighten up the mirror lock screws. Just gently tighten them up, and then go back to the front and make sure that nothing is moved from there. And if you look down, it's in the center and it is collimated. Done. 3 minutes at the beach with one of these and you're done. And it's a lot easier to do in the dark when you have one of these. Now, you're just getting into astronomy, just got your scope. You don't have all the fancy accessories that a few of us might have. So you say, how do I collimate it without that? Most new scopes come with an eyepiece cap that looks like this style. You can buy a Collimation Cap, and what it is this style of cap. I made this one this week because I didn't have one. I drilled a 3/32 hole in the center. Then I went into the kitchen and I got some tin foil. And I put a little bit of tin foil in there and I glued it in. And what the tin foil allows for is the reflection of light. So if I take this cap and put it in and tighten it so it doesn't move, I'm going to look in first and see if I can see the primary mirror. Now there's 3 little holders on the primary mirror. I'm going to show you what these are. I'm just going to share this for a second, if I may. And share screen. Share. You should see 3 circles.
Yep.
One with 3 red lines coming down. When you look in through this pinhole, what you might see is this first picture. There's 3 little tabs. 1, 2, and the third tab is not there because the mirror is not centered. If you look in the second one, we've already gone through the secondary mirror and everything is aligned, and then we'll align the primary after that. But you're looking for these 3 tabs to be evenly spaced in a circle around the center from this in this first photograph. So you're going to take your Allen key or your screwdriver onto the secondary mirror. You're going to put it into one of those 3 little slots that are on the secondary mirror, and you're going to adjust it ever so slowly. And don't worry about trying to get the actual center of the eyepiece. You're looking to get the primary mirror centered in the eyepiece. And so you're going to manipulate these little screws on the secondary mirror ever so gently until when you're looking in, you'll see what looks like this second picture here. You'll see the 3 tabs holding the primary mirror. And it'll be a perfect circle. And you know that now you are centered mirror to mirror from primary to secondary. If the little circle that you look at is off to one side or the other side, that just means that your primary mirror has to be adjusted. That's when you go to the back, you undo your locking screws, and you ever so gently turn the 3 collimation screws at the back until that dot lines up in the center like it does in the third picture here. And once you see that, you are totally and correctly collimated. Now, it won't be as good as a laser collimator, but it'll get you really, 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 really close. And if you want to get closer after that, you can actually do a star collimation. But making this eyepiece is collimator cap is very, very simple. I'll stop sharing again. Like I said, there's not much to it. You just take the cap, drill a 3/32 hole in the center, glue a little bit of tin foil on the inside because you want that reflection of the light, and you got yourself what they call an eyepiece collimation cap. Oh, I hear Rosetta's fun fact.
Fun fact.
It's Mike's fun fact.
You're a little early, Paul.
Wrong button.
Mike's fun fact.
Sorry about that.
So that's as simple as it is. If you don't have an eyepiece cap like that, but you have some old 35 millimeter film canisters, you can do the same thing. What you do is the film canister like this, the cap on it, on this end, you cut the bottom off so it's a big hole, right? You can look right through. On the cap, you put a little 3/32 hole dead center. You slide it in, and there's your collimation cap again. You just made one. You don't have to go out and purchase one. I looked up the price of these are $27, believe it or not, if they didn't send you one with your scope. Okay. The price of these you can get from SV Boney now are about $37 for a laser collimator.
Everybody, Mike is selling those caps for $19.99.
Yeah, I will. I can. You can 3D print them.
Free shipping.
Free shipping, yeah.
They're very simple to do. And if, as Paul showed last week, if you're in the house or you're in the garage, it's not quite dark, or you can't collimate on a star, you can get something. And I found mine. It's called an artificial star, and I can bring it up here. And what it is an LED flashlight, and it's got 5 different size holes in it. And when you turn on the flashlight, the light shines through those, and you set it up on a tripod, maybe 15 feet away or 20 feet away from your scope, and you point it at your scope, and now you've got yourself an artificial star to collimate your telescope on. Handy thing to have. We've used these quite a few times at Fun Day, haven't we, Paul? To get ourselves together. I forget what the cost is, but they're not much.
They're about $20.
If you got a reflector telescope, it's worth spending the money and getting yourself one. Yeah, you want to be able to be self-sufficient when you're out there. You get out and all of a sudden you don't have the tools or the caps and stuff you need on your own. Then you're running around borrowing from people, and I'm known for that at the star parties. I got all kinds of goodies come and see me, and that's what we do. But if there's any questions, that's the plain and simple of how you collimate your scope.
Okay, so tell you, Mike, I got a couple of things here.
Yeah.
Jeff asked, if possible, Mike, can you share or send the image you presented? Don't know if you can do that. Maybe what you can do is bring it back up on the screen again, just by itself.
Yeah, they can do a
I'll pin
screenshot.
it, and then I'll let Jeff. You can do a screenshot, and I can let Jeff snap a picture of it if he likes. What I can do is I can get Mike to send it to me after our live feed, and I can put it up on our post. So let me pin this up first of all. There we go. So Jeff, hopefully that'll help you there. Just get a screen capture of that with your phone. Leave it up for a minute or so.
That was one of the first 6 images that popped up when I typed in on Google Collimation eyepiece and clicked images.
It's an awesome picture right there. That really does explain it. There's a couple of things I was going to ask. Like number one is if you got a really sloppy focuser and you want it to collimate your scope, like when you put your laser collimator in there.
Yeah.
And you have to make sure that you tighten your screw. So when I was doing mine, I guess I was kind of putting my eyepiece or my focuser to the spot where I would normally have it set, kind of thing, for focus, and then adjust from there. Was that what you would recommend, or?
I put it all the way in.
All the way in, okay.
So it's solid. Then I adjust the mirrors from there.
Okay, all right.
That's
So
just
if
how I've done it.
if it's a little bit sloppy, just make sure your screws are tight, just as if you had an eyepiece in there. Okay, I'm going to take this back out here again. I'm going to
Mike, I didn't notice, but did you show what stars look like through the telescope out of when your scope's out of collimation?
No, I don't know. You have a picture of that?
Yeah, I'll bring it up for you.
Okay, I'll stop sharing. Everybody got that? Or I'll send you that picture as well, Chris.
Yeah, if you can send it to me, I'll put it up on the Facebook page afterwards, and the link to it at least, yeah.
Sounds good.
Will it be available for download, Kim says. Well, Kim, you could always go back and just pause the video afterwards and screen capture it, and then you'll have it for yourself.
Might I suggest you just Google Collimation eyepiece,
Okay.
and then click images on your browser, and that picture will be somewhere on the first screen of images that you see.
Awesome. Okay.
So here's can you see that screen okay?
I'm just going to pin it, Paul, for you too.
Sure.
Okay. Yep, there we go.
So when you get a Newtonian, like what Mike's got there, and it's out of collimation, it's called coma. And coma is, they kind of look like little arrows. They look little arrowheads off the end of an arrow is what they look like. So this basically is in focus, out of focus. And these images that you see are due to coma from your telescope, which is probably out of collimation or miscollimated or out of collimation. So when you look at a star, you're going to see the star, but you're going to see this aberration around the edge, usually pointing to one side or another. And then, so that would be slight, excuse me, in focus coma. Severe coma will look more like that. It almost looks like a headlight. You see the point of light in the center, and then it shoots out like that. If you're seeing anything like that when you're looking through your eyepiece, no matter how tight you make that star, that's when you know that you have coma and you have to do some collimation. So that's what you'll see through the eyepiece through your telescope.
Awesome, Paul. Thanks.
Perfect.
Okay. I'll stop sharing.
One other thing I was going to mention was maybe another idea is if you have a spare 1.25" eyepiece or an eyepiece that you just don't want anymore, like a cheap $5 or $10 eyepiece that you bought somewhere, you can always untwist the barrel off of it, and then take the cap that you would put normally on the eyepiece and just take that whole piece with the cap and the barrel, flip it upside down, and drill a hole through it, and then drop that into your scope, and that'll also act as something like a cap if you didn't have the cap. So
Yeah, all you're looking for is a pinhole to look through.
right.
The smaller the hole, the better. I found that a 3/32 hole was perfect for me. They say it should be no bigger than your pupil.
Right.
The hole. So
Rob's asking what's it worth, so I'm assuming he's referring to the laser collimator.
they're running about $30 on eBay and Amazon, depending on where you shop.
Right.
Yeah.
Like I said, the Collimation Cap is running the same price, so why not buy the laser?
Yeah. Yeah.
It's far more accurate and easier to use.
Now it is possible for your laser collimator to be out of collimation, and that can happen.
You can check that too.
Yeah.
You can make this just a little, almost like a half of a lazy Susan.
Yeah.
And you just make two of them. And you just set your collimator right in it, turn it on, and just slowly turn it. And if your collimator light starts doing this against the wall,
Like an oval, yeah.
collimation.
Yeah.
So
And there are usually 3 adjustment screws around that allow you to adjust that beam. So yeah, just maybe make a little small circle on the wall that you can see that it's going around it. And if you can get it to stay inside the circle, then you're good.
Yeah.
I've even seen a couple where they've taken 2 nails, kind of drove in this way and then 2 that way.
Yeah.
A piece of board and then set it in that as well.
Yep.
So yeah.
Now, here's the
That'll
easy
keep-
part. Usually the secondary mirrors, usually they use a 2mm Allen key. Guess what the laser collimator uses? 2mm Allen key.
Yeah.
So you're using the same Allen key for everything. That's the convenience of it.
And make sure
Yeah.
too that your telescope is basically horizontal when you're doing that, especially when you're adjusting the secondary. Because if you have it up this way, if you happen to drop that Allen key, it's going to fall down and hit your mirror on the bottom. So try to keep your scope fairly horizontal while you're trying to do your collimation.
Yeah. Like Paul said, Bob's knobs is the way to
Yeah.
go. If you're going to stay with a reflector, it's worth investing in a set of Bob's knobs.
Yeah.
They're around $40, I think, give or take, depending on the
Yeah.
scope.
yeah, that's about right by the time you get them.
I
Ship
think
to
you can
you,
even
yeah.
go to Home Depot, have those little baskets of individual parts, and they kind of spin around. I've seen them at Home Depot, like all these different oddball type screws and stuff like that. Kent actually has them too. They have trays that slide out. You can actually get them there as well with like a little thumb screw on them, like a wing nut basically, a wing bolt, and you can buy them in the same size. So you just take one of them out with you and compare it, get the same size. But yeah, you
As
can
long
buy
as you
them.
get the same thread, yeah.
That's it. Yeah.
If you can get,
The other thing I came across when I was looking at some stuff was these artificial stars. If you don't want to buy one, you can actually make one. And it's really, really kind of simple as long as you have an LED flashlight. You take the top off so that you can get at the glass, put a piece of tin foil inside or on the outside, and you want to find the smallest sewing pin that you have in your closet. Everybody still has, a needle, a sewing needle, and all you want to do is just the smallest prick in the tin foil, and that will come out, and believe it or not, it'll give you a nice artificial star.
Nice.
So they are easy to make. A lot easier, cheaper to make than buying one, but if you can get it for free, why not, right?
Yeah.
See, Jeff Legier posted here. Found it. Thanks. Jeff posted the link on there with the Collimation guide. So thanks, Jeff, for that.
Awesome.
Great. Okay. So I guess we get all the questions answered. We're going to move from. Thanks, Mike, for that. Appreciate that. All good information. All great for anybody who needs to collimatoscope. And it's easy to find out if you're out of collimation too, as you just defocus a star. Have a star in your field of view and defocus it to see if your rings are all concentric, like they're all the same distance apart, right? Okay. From there, we're going to go to Paul's going to give us his Rosanna's fun facts. Are we doing that now, Paul?
Yeah. I will
right.
see if I can pull this off.
I'm sure you can.
It's always it seems to be a journey each week.
Yeah, but that's why we do it live.
Indeed. Okay, let's see if we can present now.
Okay.
And I'm gonna get the right screen and we can present. And she disappeared on me. There she is. All right, so now we're getting for this week's
Rosanna's Fun Fact.
Awesome.
Yay!
Hey, welcome back, Rosanna. Good to see you again. Oh, and Rosanna's got a really cool fun fact this week. And actually, I learned quite a little bit from it on a whole bunch of things that I did not know.
I did not know that.
You did not know that. Ed McMahon will be saying that throughout this whole fun fact, I think, this week. So here we go. So Rosanna, so she writes, "Hi, Paul. Seeing is believing, or is it? I have a friend who is colorblind. Knowing this always weighs heavy on me when we are looking at art, photos, and especially astrophotos. Astronomers and just about everyone are enthralled with pics from Hubble or just looking at different color stars in our backyards. This line of thought led me to wonder, how would color blindness affect someone with an interest in astronomy? How would their view of outer space worlds compare to a normal sighted person's?" So amazingly, the greatest observer of Mars in the 19th century was actually colorblind. So there. So he discovered the red planet and he was colorblind. Unbelievable. Didn't discover the planet, there's some things about it. This was the Italian astronomer Giovanni Vergino Scarpelli, pronounced Scaparelli. So Giovanni created a classic compilation of Martian observations, La Plante Mars, published in 1892. This work has been referred to and influenced by astronomers to follow since. Giovanni also made brilliant investigations in the 1860s, which showed that the August meteors followed the same orbit as the comet Swift-Tuttle, thereby forging a link between comets and meteors. And it was Giovanni's who devised a new scheme of naming features on Mars. Now, a scheme based on the geography and mythology of the classical world, thus introducing names which had ever since been part and parcel of the romantic lore of the red planet. Sirius Major, let me just put it on here first, hold on. There we go. So we have Sirius Major, Sinus Abius, Margariferator, Sinus. I can hardly say these ones, but anyway, there's a bunch of them there, as you can see. And of course, Rosanna's favorite is Elysium, a volcanic province home to a lonely volcano. Now, you may have even have been familiar with the term cannelli, not cannoli, that had been used to describe a class of minor features. Now, Giovanni had channels in mind rather than canals. But of course, it was translated as canals with a fateful shift in the meaning for later interpretations of the planet. So many books and many hysteria developed about the potential of man-made canals on Mars. So, but how did Red Planet look to Giovanni? We now know that the red-green color blindness is due to the fact that the normal long wavelength cone photopigment is missing. Those who are colorblind have a deficient perception of all colors, though the main difference is that of red and its complementary color green. Most colors are shades of gray, with yellow being in the best color seen, but colorblind individuals are actually more sensitive to the to contrast, a fact which may have contributed to the micrometric kinesis of Scapelli's sight, thus his amazing ability to see and sketch details that were lost to others. Here's a comparison for various types of colorblind vision. So she shows 4 different types of color blindness. So, excuse me. So the one that Giovanni had was protanopia. And so what would look red and green to us would look very all green to him, but with different shades. And again, this is where she's talking about having the ability to see detail with shades. I'll make that a little bigger for those folks who can see that a little bit better. So if you're in the supermarket shopping for a specific kind of apple, you may have a little bit of problem if you're doing it based on color. But I think based on markings is what a lot of colorblind people get used to, and the various shades and where those shades are, and they learn to adapt that way, which is really quite striking, really. So there is a wonderful and fascinating article on his life, and it explains many of the nuances of colors that the astronomer's personal peculiar eyesight led them to believe that they saw on Mars: blues, greens, yellows. We now know that both the light and the dark areas of Mars reflect most strongly in the reddish part of the spectrum. The blue-green tints are then entirely illusory due to the eye's own peculiar organization. Later on, in 1881 to 1882, Giovanni reported bizarre doublings of the canals, which he called gementations. He suspected eye fatigue or strabismus, but then became convinced that the seasonal phenomena were real. It would seem, in truth, it was the result of some type of eyeball pathology. No other observer could see the gementations to that same extent that he could. Something to note is how many astronomers have said they viewed the colors blue, green, etc. on Mars. The article ends with, the irony is that astronomers may have come closer to a faithful representation of the tantalizing disk, Mars, had they spent more time focused on what was happening on the small end of the telescope. And now she finishes with a cute little cartoon. So here's Linus and Charlie Brown and Lucy up on the hill. And Lucy says, aren't the clouds beautiful? They look like big balls of cotton. I could just lie here all day and watch them drift by. If you use your imagination, you can see lots of things in the cloud formations. What do you think you see, Linus? Well, those clouds up there look to me like a map of the British Honduras on the Caribbean. That cloud up there looks like a little like a profile of Thomas Eakins, the famous painter and sculptor. And that group of clouds over there gives me the impression of the stoning of Stephen. I can see the Apostle Paul standing there to one side. Aha, that's very good, Lucy said. What do you see in the clouds, Charlie Brown? Well, I was going to say I saw a ducky and a horsey, but I changed my mind. Yeah, it is.
Rosanna's Fun Fact.
Awesome.
Thank you
Well
so
done.
much, Rosanna. That was so entertaining.
Awesome.
And I learned so many things.
I just wondered if he had a hard time picking crab apples because they were all green.
But the That was one of the funner ones.
Something else.
That was awesome.
I
Yeah.
really enjoyed that, and learned a lot about colorblind people.
There you
That's
go.
amazing.
Yeah.
So the guy that had come up with all kinds of stuff on Mars, he didn't see red.
Wow.
Ironic, isn't it?
On a red planet.
There's a tale out there that's why stoplights were set up the way they were, like the red on top and green on bottom, but I'm not sure if that's true or not. But because people are red-green colorblind a lot, right?
Oh, yeah, they are in specific order, aren't they? Isn't that something?
There's a red light on those?
Well, there's
I thought they were
green.
yellow and green.
Yeah, green means
So the
go,
next
red
time
means
you have a
stop,
red
and
light, you can say to the cop, "Well, I'm colorblind,"
that's it.
and I couldn't remember the order.
And dyslexic.
I saw those green lights coming from behind me. So I pulled over.
Yeah, I've been trained not to stop for them. Yeah. Green means go, red means stop, and yellow means go very fast.
Exactly.
Okay, so we're going to move on now to our binocular target of the week. I think we're going to go with that, and then we're going to show pictures at the end here. So get a number of nice pictures that come in.
Let's hope get rid of this.
Okay.
Where am I starting?
Thanks for that, Paul. Thanks for that, Rosanna.
Yes, it was wonderful.
Awesome talk.
Entire screen of some sort. Pick this one. Okie dokie. We should see
Bye, bud.
Bob.
Da-da-da-da-da-da.
By himself.
He is.
Make sure I got the right screen.
Yep.
I had twins up there. If you see, you were seeing double. But
I'll pin
so,
him.
being that we have another contest coming up, or we're actually started, Bino Bob's target of the week is the moon. It took me a while to get that makeup on.
I bet it did. That's icing, isn't it? Vanilla icing.
As you guess. So the moon is Earth's only proper natural satellite. At 1/4 of the diameter of the Earth, comparable to the width of Australia, it is the largest natural satellite in the solar system relative to the size of its planet, and the 5th largest satellite in the solar system overall. Orbiting Earth at an average lunar distance of 384,000 kilometers, give or take 1 or 2, or about 30 times the Earth diameter, its gravitational influence is the main driver of Earth's tides and slightly lengthens Earth's day. The moon is classified as a planetary mass object and differentiated rocky body and lacks any significant atmosphere, hydrosphere, or magnetic field. Its surface gravity is about 1/6 of Earth. Jupiter's moon Io is the only satellite in the solar system known to have a higher surface gravity and density. That's just a quick little blurb. If you were to go outside right now and the clouds are breaking up and you held your compass and you spun your body around to 252 degrees to the west-southwest and look straight up, you will see the moon in Gemini. It's almost actually dead center in Gemini.
Yep.
It's real easy to find. I'd say find Gemini and you'll see the moon, but now it's going to be find the moon and you'll see Gemini. So it's approximately 37% lit right now, so it's not quite halfway there yet. What will you see when you look at it? You'll see the Terminator line for sure. You can see some of the seas or Mira. You'll see some craters, and there's still some earth shine there a little bit. As it gets closer to half, that starts to go away. If you were looking through a set of 10 by 50 binoculars, this is what the moon would look like right now. So it's actually, you can make out a lot of detail, believe it or not, with just a pair of 10 by 50s. More detail than this poor lady can see right now.
But she's got 2 rolls of toilet paper, so they're pretty valuable.
This is the new COVID binoculars. They keep you safe, but you can't see nothing.
That's a pretty tough decision.
That's our binocular target of the week. If you get a chance, go out, look at the moon, and shoot the moon, because we have a contest going on.
We do, indeed. Yes. Thanks, Mike. So, yeah, the moon's a great target. Always a great target for your eyeballs in for cameras and for telescopes, binoculars. And for that poor little old lady there, we should get her a set of binoculars.
Yeah.
Okay, that's our binocular target of the week. And we're going to go from here to, we got 9 minutes left, so let's move into photos, I guess. I got a few photos to share. I didn't bring all of the ones over from the moon contest right now, but I just grabbed a few just to try to encourage people to get out and do the same thing. So I'm going to do my share here, first of all on the screen. Entire screen. And this one. Okay, first up is Kathy Adams. Oh, shared on the wrong screen. Look at that. Why did it do that? Let's see if you still see it. Let's see if you see it now.
Yes, sir.
Great. Oh, okay. Kathy says it was so nice, she says, to have some nice nights. Always loved the Orion and the Hyades and Pleiades were cool too. So she had the moon here, and she also has Hyades and Pleiades. There's Orion sitting in there.
Right.
Awesome, Kathy. Great shots. Nice
The
detail
blue
there.
hour too, eh?
Beautiful.
Yeah.
Love the reflections.
The blue hour. I
Yeah.
like that. David Smard sent in the moon. Said a bit cloudy tonight, but he did get a nice capture of it there.
Yeah. Some earth shine there as well.
Yeah. Awesome, David. We got another one here from Kathy. Some more here from Kathy. Kathy said the moon was awesome tonight, she says, and the sky was a beautiful deep blue when I shot the picture of it. It went out again. I went out again later and took a picture of the Big Dipper. She said great fun and where's she at now? Yeah, there. Great fun and no skunk this time, she said. So awesome. That always makes a difference.
Excellent.
And that's
I
her
smell a
shot
good
there.
picture.
Yeah. Okay, and we're going to move on from there to Stefan. Stefan sent us a picture in of Mizar and Alcor. He says, here's my rough capture of Mizar and Alcor after Mike's target of the week, but I obviously didn't use binoculars. He said I cheated and used my 6SE with the SV Bony planetary camera, which explains the field of view. This is from Wednesday night at around 9:15. Well, we don't care what you used. I'm not going to say that you cheated. We still appreciate the shot. So
Nice shot.
Yeah.
Like it.
I go from here to Millie Bolivar, who said took this tonight for the contest. Thank you. This was a couple of days ago, so we're getting some nice moon shots in.
Yeah, nice color on it.
And Joanne Armstrong Morris sent this one in from beautiful Trout River, Newfoundland. Look at that.
Wow.
Look at that sky, eh?
A nice,
Gorgeous.
Wow. Nice moons too.
Nice moons. Awesome. Thank you very much for that, Joanne, sorry. Lisa Fanning sent this one in, dodging clouds, she says, with the moon. So always nice when you get clouds in the shot like that.
Oh, that's nice.
Great capture.
Yeah.
And finally, I get these ones from Bruce Kasuji. Bruce says, hi, Chris. We were treated to a wonderful light show this week. I watched for several hours as the northern lights changed constantly. At first, I thought they were high clouds moving in. A glowing haze slowly appeared in the northeast, he says. Suddenly, a streak of bright green writhed up the sky, and then the lights were everywhere. This sounds like a Dave McCashin talk.
Yeah.
Very, very descriptive. I love the descriptions. These are great. Several times.
Sorry, you can see some of the red, because every once in a while you can see a little bit of red in them.
Yeah.
Yeah, right there. Yeah.
Yeah, awesome. Several times they faded to the haze before lighting up our northern British Columbia sky, he says. Thank you and the team for all you do to share your knowledge and passion for our night sky. Look at that.
Maybe look at that one, eh? The ribbons. Love that.
He's got another one here.
Oh, sweet.
Awesome.
Unbelievable. Very nice.
I'm taking a trip north when traveling.
You bet. Just for that alone. Other awesome
amazing.
pictures. Thanks everybody for those. We always love getting your photos, and if you'd like to send them in to us, we'd like to get them here at Sunday Night Astronomy Show at gmail.com, or you can send them into my page as well, of course. And I try to share everyone I get. If I can get them before noon on the Sunday, that's always best, because I'm usually not at the computer too much longer after noon for the show wrap up. Anyway, so get them in by Sunday at noon, and I can certainly share them up on our page. Let everybody take a look at some of your work. Now, this other thing I wanted to talk about just for a couple of minutes here was the Shoot the Moon contest that's current right now as well, as Mike mentioned. So this is the contest. These are the books that are available. We've got 3 books being offered by John Reed, who is our local author out of Halifax, and John is the author of this series of books, 50 Things to See books. They're bestsellers on Amazon. They're very popular books. One that he's given us, or 2 he's given us, is 50 Things to See on the Moon, First Time Stargazer's Guide, and 50 Things to See with a Telescope as well. I'm also including the book Night Watch, which is a practical guide to viewing the universe. It's usually our first best book to get you started in the hobby. If you're looking at trying to find out where things are in the night sky, there's some really nice night sky maps in there as well. But it takes you right through our location in the universe, where we are located, and it talks about all different types of telescopes, binoculars, everything you really want to learn about the night sky to get yourself started is in this book here. It is called A Practical Guide to Viewing the Universe, and it really is a practical guide. And along with that, when you're looking at your star maps, you're going to get this red LED flashlight, which is always excellent for us when you want to try to protect your night vision at night. A red flashlight is best. You can't protect it completely, but that does the least amount of damage to your night vision. So that'll go along with it. And also I've included these moon calendars. So these are roughly about 4 by 8 inches long, I guess. And they can put a couple of fridge magnets on it, and it's on your fridge for a while, and you can tell what phase the moon's going to be tonight, right through your 12 months of the year. So they're going to be included as well. For each of the books, you'll get one of those. So the contest ends on the 28th, which is the night after the full moon. So, and I don't ask for anything special. There's no judging being done at all on the photos. Go out. I know that smartphones take a very tiny picture of the moon. That doesn't matter. The idea here is that you've taken a new picture of the moon, so something through this cycle, and I'm not looking for a full moon at the first of the contest. So something new for the cycle, and any picture at all of the moon with an iPad or whatever you got for a camera, it doesn't really matter. Send it in, and your name gets entered. Share the contest, and your name gets entered twice. And these are the prizes that will be drawn on the 30th of April. So let's get some entries. Can't get an easier contest than that, I don't think. And from there, I want to share one more topic, which is this one, which is our upcoming workshop called The Beginner's Guide to Astronomy. And it really is a beginner's guide, so we're going to have, it's going to take place over 4 weeks from 7 to 9 p.m. starting on May the 5th, so it'll be 4 Wednesday nights. Myself, Paul, and Mike will be putting on the course. There'll be topics, basically under the night sky will be the first week, where are places in the universe, that type of thing, how to find things in the night sky. Second week is going to be more about equipment basics, so basics about telescopes, types of telescopes, binoculars, accessories, that type of thing. Our third week is going to be Paul bringing my topic and Mike's topic together to talk about astrophotography, how to image the moon, how to look at how to image the Milky Way, maybe time lapse, whatever Paul has in mind for his topic. And then our final week is going to be more of a wrap up, and if you have questions that you have about your telescope or about your binoculars or anything along that line, we're going to wrap that up on the final week. So there'll be 4 weeks altogether. There'll be about 90-minute sessions with a short Q&A period for each one. I did put a post up on my Facebook page about it. I'm going to put up an event post probably Wednesday or Thursday of this week, so if you are interested, watch for the post coming up on Wednesday or Thursday night. It is going to be offered the same way as we do our Sunday night astronomy show here. It'll be on a Google Meets invite. So once I get the list of attendees, we'll compile all the email addresses together, and we'll send out a link for everybody to be able to join. Now, it doesn't matter if it's one person in the house or family that want to sit there and watch it. That's fine too. As long as one membership or one registration is paid for, then you're more than welcome to share it with everybody. So that's coming up starting on the 5th of May at the moment. If that changes, we will let you know. And that's about it. I guess that's all I really want to share. So we're coming back to stop presenting. How's that, guys? The cover part of it, I guess.
Yep.
The first time we finished on time.
And it is 9 o'clock. Look at that. Wow. Awesome. Okay. So next week's show, for my topic, I'm going to start talking about the Voyager spacecraft, something that I've been interested in since 1977. I've been following that. Every couple of months I go back and take a look at the website and see how it's doing. So my talk for this Where Are They Now talk is going to start to talk about the Voyager spacecraft. It's probably going to take a few weeks, though, to cover all of the material. So next week will be about Voyager 1 and what it did in the solar system, then following week Voyager 2, and then a wrap-up of the Voyager interstellar mission, we're calling it now, where they are now outside the solar system's bubble, and they're actually in the space between the stars, and what will be happening with them as we talk about them almost 50 years later. Like, this is amazing to see spacecraft that they're still talking to almost 50 years later. These guys are getting really good at reliability with these missions. Actually, they had to go out and find people that had retired and brought them back and trained young guys on the code, how to talk to the Voyager spacecraft back and forth, because they had to tell one of them to do a certain thing, which I'll talk about in the mission, but about in the talks. But it's amazing that they had to go that far back to bring retired people
right?
back.
Because it was all written in cursive.
Yeah.
Yeah, exactly. Yeah. Well, stone tablets, right? With stones, and they used abacuses and that kind of stuff. So, yeah. He's a comedian. Okay. Anyway, well, folks, I want to say, I guess that's probably our night. So let's take a second and I'll wrap up. So in closing tonight, then, our special thanks again for your continued support out there. We really do appreciate it. We appreciate when you do share the program as well, because we like to get it out to as many as we can when we're offering this program. Thanks again to Rosanna, of course, for her continued contributions to the show. We really do appreciate all your hard work in getting us your episodes. And remember, too, we do love getting your photos, so send them into SundayNightAstronomyShow@gmail.com, and we would love to show them here on the program. We're also looking for suggestions for topics for future shows, so if you have anything you would like to share with us and discuss for a future episode.
Throw it out there.
All right. Please send your request to the same address, SundayNightAstronomyShow@gmail.com, and we'll do our best to make it happen for you. Also ask that if you enjoyed the content here tonight and you joined us from YouTube, please consider giving us a like and subscribing to our channel. We really do appreciate it. And please let your family and friends know as well that we are here every Sunday night at the same time to help educate and entertain you a little bit about the night sky. So for now then, from Mike and Paul and I, stay safe everybody out there. We wish you all clear skies, and we hope to see you again here next week. And as we like to say, guys, keep your scopes pointed up.
Yeah.
Awesome. Good night, everyone. Thank you. Oh, and it's cue the music. Here it comes. I knew we could do it. Night, everyone. See you next week.